Good morning. Now I am going to share with you this presentation about the current and future agroclimatic context in areas with productive potential for European plum. We are going to see what has been going on in this season and the projection for the coming months. And we are also going to review what is projected for future climate scenarios towards this century, towards the middle of this century. The world agriculture is advancing and it is facing a more extreme and unstable climate. This is due to the large amount of heat that has been accumulated in the atmosphere that modifies the circulation patterns. We have, on the one hand, that the terrestrial equator receives a large amount of insolation during the year. Therefore, a lot of heat is accumulated near the area of the equator. And if we add more heat to this system, the areas where the heat is concentrated will move towards the poles. So, the arid climate will be a move towards the central zone. We have been seeing that. And that affects the subhumid and Mediterranean climates, of course. But this is a phenomenon that goes on globally. This happens in the southern and the northern hemispheres. Weather stations in the country show this trend, and there has been a significant acceleration of warming, especially from 2010 onwards. We have seen that the maximum and the minimum temperatures have been increasing throughout the country. For example, in the middle of the last century, we had an average of 29 degrees Celsius in Santiago. And in the last 30 years, the average maximum temperature in January is 30 degrees Celsius. Here we have a map about the temperature of the warmest month that corresponds to January. And in here, we can see that in the current climate scenario, there are core areas where the hot air is concentrated. For example, in San Felipe, there are some areas like Las Cabras, where the average temperature during January gets to 31 or 32 degrees right now, currently. However, the future scenario for the middle of this century, this warming could be expressed throughout the Central Valley, practically reaching the interior of Concepcion. So that means that we expect to have hot summers with higher frequencies of heat waves. In interior areas, and probably they will be the ones that will be more affected by these heat waves. And they're the ones that have suffered the most of this anticyclone effect that in the recent years has been moving closer to the continent. This high pressure system causes the air to be compressed and confined in a thinner layer around the surface, causing episodes of high heat, and where the temperature rises many times in summer over 36 degrees, especially in years of La Nina. So in the future, these years, these heat waves, when we have La Nina, will be more frequent and more prolonged. In the other hand, in the temperatures of the year, we have the minimum temperature of July. We can see a map here on the right hand side where there is a zone in the coastal zone of O'Higgins. And it is very important to show this detail because many times there are scales where we see all of the regions. We do not see these zones that are formed, which are microclimates that occur in small coastal areas that offer specific microclimatic conditions. For example, there are areas where the greatest winter colds accumulate, but also, on the other hand, we have frosts that are more probable. So these are zones that in the future will present climatic conditions, microclimatic conditions that could have greater aptitudes because they will be less exposed to heat waves because they will receive an important marine influence. As for the minimum temperatures, we expect to have an increase of about 1.5 degrees on average. which obviously is going to generate warmer winters, with the consequence that the accumulation of cold hours will decrease. For example, in interior areas where there is normally an accumulation of 1,200 hours of cold, we could have 700 or 800 units, which is still acceptable for the European level, but it is for the European standards that's acceptable, but it is probably going to be a better solution for winters in years that there is less cold and warmer years. The consequences of this increase in temperature have been reflected in these accumulations during the winter. Here we have the Curicó station, the hours of cold. We have seen that they have decreased by around 10% compared to the 70s, and also the portions of cold. At the beginning of the 70s, it was common to have accumulation of portions of cold about 80 or 85. However, in recent years, in the mid 70s, it changed. So it is enough for the European plan, anyways. For precipitation, we hope to see a decrease that could reach about a 10 or a 15%, which would maintain this more arid condition to which we have been accustomed in recent years. This is consistent to what the weather stations in the country show. But there's an important fact here that we need to mention, and it is that there has been a slight increase in spring and summer precipitation. This gives us a little bit of hope that these waters can be used if there is a greater development of infrastructure to store these waters that are currently not being used in 100%. Climate change models predict that the total number of frosts in the future could decrease. However, polar events will continue to occur. We have already seen this in recent years, and despite the fact that the minimum temperatures have increased, we still have these sporadic events that are intense and that represent an important risk to take into account in the planning of where we are going to choose the sectors that are chosen for this event. To model a little bit the consequences of climate change and the productivity and the suitable areas of the European plum, we have developed a model that considers the different technological phases of a crop, and at each stage, it's going to evaluate the risks to which it's exposed. The idea is to develop an index that assesses the degree of compliance with climatic requirements for this species during each stage of development. In a first stage, we are going to count the cold hours. And in the case of European plum, we have considered a variety that requires about 1,000 hours of cold, a more demanding variety in cold. And in the baseline that corresponds to the current climate scenario, we see that in general, in the Central Valley, in the interior areas, this accumulation is adequate. Only towards the coast, the sectors begin to appear that have a slight deficiency of winter cold. But in a future scenario, there could be areas that have a slight deficiency. So that will force us to make a better execution of the winter resource. Many areas only have a slight deficiency, so this can be overcome and managed with technology. But there's other areas that begin to appear with a darker orange, and probably they will require a tighter control and probably a change of varieties that are less demanding. Then in spring, we are going to take into account the frosts the minimum and the maximum temperatures that will condition the success of pollination and set-in. And in the current climate scenario, we can see that there's a slight deficiency in temperatures in most of the Central Valley. And this is due to the fact that, in general, in Chile, temperatures tend to be a little bit cold. Springs tend to be cold, the minimum temperatures are cold. This compared to other Mediterranean areas in the world. But this is a slight deficiency, and in no way it depends something that is decisive for production. In the future, we see that the area with adequate ranges extends widely throughout the country. This is a positive effect of climate change. We can see that precipitation in bloom becomes excessive towards the foothills and towards the south of the Araucanía region. This is a situation that could be less risky in the future because of the reduction of rainfall. And towards the final stage of the crop, we will evaluate the maximum and the minimum temperatures during this last stage of summer, where we are going to see important processes such as differentiation, oral differentiation, the progression of maturation, the quality of the fruit, the development of color, the balance of sugar, the acidity. And here we're also going to check the sun exposure for the fruit. This is the risk index in the central zone. In general, the risks are low because, well, the European plum tends to be tolerant to the temperatures that currently exist. But in a future scenario, there could begin to appear areas with a slight thermal stress. So this indicates that we will have to use technology to mitigate the negative effects in increasing temperatures. Probably the use of chemical or physical screens that will allow us to minimize the risks and to maintain in a certain way the productivity of the yields that are obtained today in these areas. So finally, integrating all of these factors in the different stages of crop development, we have the aeroclimatic aptitude. The green colors are showing the areas that show the biggest productive potential, so where the risks are minimized. And we can also see that in the current climate scenario, they correspond to areas of the Central Bay and all the Central Valley, and also with zones with a marine influence in O'Higgins and El Maule, and also in the north of the Biobío region. This is a scenario for the future where we could see different obstructions that are related to the reduction of the cold times and the other thermal aspects. In yellow, we also see areas that have a potential, but we start seeing several warnings that we need to consider. We already mentioned them before. It is important to highlight here the increase that we could see in the south of the Biobío region and also in the north of the Araucanía region. The potential could increase in this area because there could be better thermal conditions. And they are zones that, on the other hand, are going to have more water resources, differently to the Central Valley, that is being less and less scarce. We also need to say that there are coastal zones in O'Higgins and El Maule, and also at the foothills, where we could have the current yields. We could maintain them. So let's check what is expected for this season, for this year 2022. For March and for April, we still have more cold waters in the Pacific Ocean. So we are in the presence of La Niña, and that is going to generate a block of the fronts that are not going to allow for them to go to the central valley. But in April, May, and June, we're going to see an increase in the likelihood that we will start seeing neutral waters, and that would facilitate the entrance of the different fronts in the central zone, and hopefully the precipitation, if this trend is maintained, we could see that normalized for June or for August, and these would be normal precipitations, or at least it could be a better year than last year in terms of precipitation. But for us to have rain in Chile, we have to have three main factors. One of them is the Antarctic Oscillation that is this part of this ring, this belt of low pressures. We are going to have an engine effect that is going to move this ring in this direction to the continent, and it's going to take the vapor that is generated in the Pacific to more calotte zones of the ocean, and it's going to put it closer to the coasts of our country. When the Antarctic Oscillation is moved towards the north, more towards the equator, we're going to see the conditions for the front to arrive to Chile. On the other hand, we also need to have an ocean that is going to be warm enough so that vapor is not diluted in the ocean, and for this trajectory to continue to the continent. On the other hand, we have the anticyclone that is going to generate high pressures, and that also has a blocking effect. And we need for this anticyclone to leave to the north so that it allows for the entrance of these fronts that produce rain. During February, we saw that this oscillation was closer to the equator. The negative values are going to indicate when the activity of this Antarctic Oscillation comes closer to the north, generating favorable conditions for the precipitations. And now we see a trend towards negative values, so favorable conditions. And this activity of the Antarctic Oscillation is the one that allowed to generate precipitation in Temuco and Puerto Montt during the months of February and the start of March. However, in the central zone, we still have a strong deficit of precipitation that could be normalized if this trend continues towards a warming of the Pacific waters. The precipitation should start being normalized then in May, June, more or less. Now, about the maximum temperature. In this season, in the central zone, the temperatures were very close to normal. Just from El Maule region and in El Biobío region, we had heat waves that affected the Central Valley, generating conditions that were different in this zone. But in the northern area and in the metropolitan region, in Valparaíso in general, the temperatures were maintained in normal ranges. For the next months, we hope that the temperature is going to be maintained slightly over the normal. We still expect that for the fall, we're going to have certain precipitation lower than regular, and we hope that this is going to be reverted from June or May, maybe the beginning of May, June onwards, having hope, right, to have a normal year in precipitation. Okay, so as a synthesis, we can say that the plum tree is going to find threats because of climate change, but many of them can be overcome with technology, with existing technology that is going to be applied and that is being applied now, and that could allow us to minimize the negative effects of climate change. But the biggest threat in Chile is the scarcity of water. So in this sense, the action of the state is going to be key because we need to improve the water infrastructure that will ensure irrigation in areas that are being very affected by precipitation. Now, an important point to highlight, as we saw in the maps, is the impact of climate change. And in zones such as O'Higgins and Maule, in coastal zones and at foothills, the productivity could be maintained because these are zones that are going to be less exposed to the heat waves. So they are zones where the relationship to the water to production is going to be much more favorable compared to interior climates. So there are going to be areas where we can see different poles of development for future projects for irrigation. Thank you very much.